Testing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And welcome to today's panel discussion, Conformal Coatings in a Miniaturized World. As form factors and assemblies get smaller, the challenges to prepare, clean and apply coatings become increasingly challenging. Our panel here is going to discuss some of these challenges and perhaps some of the options for choosing the right coating and process for each application. I'm joined on the extreme left by Marcus Weiler from Peters AG. Welcome. In the middle, we have David Greenman from Humaseal, Chase Corporation.
Thank you, Kit.
And to my left here, we have Axel Lindlof from Co-Young. So, welcome, gentlemen. Nice to see you. Let's have a good debate, and we'll kick it off with just a typical problem that a lot of operators have, and that is how do you avoid spatter when applying coatings? So we'll start off with you, Marcus, on that one.
Yeah, okay. Splatters, of course, is an annoying subject that you honestly cannot 100% avoid. You can always try, of course, to minimize it. It's a combination normally of the right to choose the right coating material in combination with the right application method. So which nozzle, which parameters, pressure and speed, for instance, are essential parameters where you have to find the right settings. To minimize these splashes. What is important and very often forgotten is already earlier when you start to design in electronics that you take into consideration that you need a certain buffer zone between areas which need to be coated and areas which have to be absolutely free of coatings. Right. So you need at least 3, maybe 5 millimeters as a buffer zone to make this possible. Another alternative probably is the dam and fill technology where you can of course, have more sharp areas between coated and uncoated areas.
Right. Okay. I mean, David, what about viscosity? Does that make a difference on how you can control spatter?
Yes, certainly. Getting the right level of viscosity and solid content combined with the equipment and the settings, get that right, and you can limit it. You can reduce it.
Right.
Also, selection of the product can also affect the splashes and the edge coverage,
right?
And the rather disgruntled edge coverage we see from time to time.
Right. So there's 3 ways to try and help avoid it a little bit, for sure.
Maybe as a rule of thumb, one can say I think that the higher the pressure and the higher the speed is, the more you will have this issue with splatters. So to reduce that will always help.
Speed is also an issue,
yeah.
You're right, absolutely. Okay. And what about, Axel, from your point of view, from detecting these coatings and things like that? How closely do you inspect it?
So spatter typically are inspected with UV light. So we check the areas which shouldn't be covered. And I can confirm it is a problem. I see a lot of customer samples coming in where we do some feasibility studies, and there are huge differences. You can see which customers are having their process, their machines under control. So the best samples usually we get from the machine builders of the coating machines because they know what they do. If you get customer samples, there you see which process is, as you said, speed optimized. So, and there we find a lot of coating in the areas where they shouldn't be. So, therefore, I can totally confirm what we hear here
Okay.
with the factors
Yeah.
of the splatters.
So back to you, Marcus, a quick question here. How can storage conditions negatively affect coating materials?
This depends a little bit on how sensitive the material itself is. So the chemistry behind high reactive materials have very often a very limited storing stability, and therefore, of course, a material which has been stored too long, then what will happen first is that the viscosity will increase, and this, of course, has a severe impact on the overall performance on the line. If you don't change parameters, it will be a disaster.
Right.
So that's mainly the main. So you have to take care on the shelf life. You have to store it best in refrigerated conditions, if possible, especially for sensitive materials. In this respect, acrylates, for instance, are completely uncritical. They have an endless, eternal shelf life in the end.
Right.
But other materials like polyurethane or UV reactive materials, silicons,
Yeah.
they can be quite critical.
Yeah, I bet. Anything to add to that, David?
Not really. Storage is the most important part. Getting the temperature right, not too hot, and in some cases not too cold. So,
what about two-part materials versus single-part materials? Do two-part materials store better, because they're not mixed?
Yeah, two-part materials will obviously have better chance of maintaining their properties when stored correctly. The other ones are the UVs, especially if you've got the moisture cross-linking property, then you've got to store those correctly, and you've got to watch your shelf life.
Right.
Because they have a shorter shelf life than some of the classics that have up to 2 years.
Right. Okay. Jumping back to you for a minute, Marcus. With larger components, how hard is it to achieve an even protective coating on the edges and the corners?
Yeah, you can't trick physics only to a limited extent.
Right.
Liquids follow the gravity and flow down from components. So there is nothing there. In general, you cannot avoid this. You will always have a lower thickness, especially on sharp edges of components or component legs. What you can do, of course, is you can optimize this by using a thixotropic coating material which has different flow characteristics.
Yep.
So you can definitely get a better edge coverage, but once again, you cannot completely trick physics.
Right. Yeah, it's very difficult. Of course, David, the other area that is challenging there is the edge definition, where the coating bleeds off the edge of the board, and sometimes if you don't fully coat that, you can get moisture ingress into the side of the board.
Yes, through the fibre itself. One thing I'd like to add is that to get good coverage, you must look at surface energy. We're always saying that you must be greater than 38 centimeters of surface energy to prevent it from capillary action, either building it up or taking it away, and also obviously de-wetting. So that has a certain effect on sharp edge coverage. It's something that in the days of through-hole technology, axial components, round components, we never really saw. The modern day sharp edge SMTs, it's something which I think we're all addressing one way or another.
Yeah, absolutely. So, Axel, from your point of view, inspecting these coatings for coverage and detecting the areas around corners or sharper objects, how easy is that, and can you detect thickness that way?
Yeah, there are some limitations, but due to our technology, so we measure through semi-transparent and transparent material directly, because we detect the refraction lines between air and coating and PCB. We can measure more or less at any spot on the board. So to the commands, we can really see that many users don't have the process under control, so that you have a complete de-wetting on the component edges, just a small hill in the center of the component. We can even measure on the component top, and component edge, for example, is also a specification, for example, in automotive industry, that you have a minimum coating on the edge. So this will be more and more important. So yeah, we can measure more or less where we want, but the best results we achieve if we have solid ground underneath. So on the component we have it, on the board we can achieve better results if there's a copper trace or a copper area, which give us a good reflective surface.
Yeah.
So and then we can measure these liquid heights in a micrometer accuracy. So in a proper accuracy down to 5 micrometer coating thickness.
Okay. So Axel, what is the optimum thickness for a conformal coating, and why is the thickness so important? Yes.
Because you mentioned Axel. Sorry.
Oh, I'm so sorry.
No deal.
There you go. That's you know the. And
so
I can't record that because we're in live television. So I'm sorry, I called you by the wrong name. So Marcus.
The best thickness for conformal coatings, that pretty much depends on the conformal coating material. So there is no general thickness. Of course, you can follow the IPC maybe, which helps, but also here the variance is quite high. So for solvent-containing conformal coatings, we are talking normally about a range of 30 to 50 microns on a flat surface. There are other systems, solvent-free systems, where you can go much higher, let's say up to 100 or in some cases even higher than that. Normally we do not recommend for standard materials, let's say with the exceptions of silicons, we would not recommend to go higher than 100 microns even with solvent-free systems, because this can have a negative effect then, this high thickness, on a temperature change test, so that it's getting cracks in a rapid temperature change environment.
Okay, and will that also depend on what the application is, whether you're using, whether it's a security application or whether it's a hydrophobic coating for cell phones or something?
You are right. Of course, it depends what exactly you want to achieve. What we normally say is the coating thickness should be as high as necessary, but as low as possible.
Right. Okay. David?
Yes, with regards to thickness and coverage, we've done some recent testing, and we've proven that with the vitrified flux residues from lead-free high temperature soldering, when you put a 100% solids polyacrylic UV curable coating on top, you get a difference of match, you get a mismatch of thermal expansion.
Right.
And with that, with thermal cycling, say minus 60 to plus 150, you're getting fissures, you're getting cracking, but without that flux residue, without that mismatch, the coating will just sit there and be as happy as anything. You do not get any cracks or fissures.
Right.
And that is why I am a supporter of, yet again, cleaning before conformally coating. It's back to where I started many moons ago with the military.
Right, but I mean, I can't stress this strongly enough. I mean, I find it hard to believe that still 80% of people are not cleaning before coating. It doesn't make a lot of sense to me, but there you go.
The pictures I see on our measurement devices are really showing that you find a lot of contamination beneath.
Yeah, you've been trapped underneath the coating. Yeah. It just doesn't make sense to me. I think. So, what about the topic of adhesion? I mean, some people are using plasma treating to get a better surface tension before applying coatings. How effective do you think that is, and what applications specifically do you think you really should use a sort of plasma treatment? You can go first this time.
Okay. Yeah. On that one, what we've found is with classic conformal coatings, with solvent-based conformal coatings, you get a little pre-wash when you apply it, and that helps the adhesion. And again, we come back to the surface energy. If it's lower than 38.9 centimeters, you could get adhesion problems. But the thing is, as you come up to the 100% solid materials, you've really got to look at that surface energy, because you've got no solvent there to wash or to combine. And you can get delamination, you can get when you're demasking, if you're doing any masking, you can pull the coating off. So it really is important to look at that surface energy.
Right. So you for or against plasma treatment?
Plasma treatment helps. We've done trials on that ourselves as well, and we found in certain circumstances it helps, but it does seem to depend on the solder resist and the other contaminants that are on top of it.
Right. Does it remove the some of the contaminants that are sitting on top of the board when you do the plasma treatment?
It will activate the surface and also remove some of the contaminations.
Right.
But in the end, as David said, it doesn't matter if you use plasma treatment or any other cleaning process. It is important really that you coat on a clean board and that you do not encapsulate residues from fluxes or solder paste underneath or in between of the printed circuit board and the coating.
Right. So would you in that case then recommend plasma treatment followed by an aqueous cleaning? Would you recommend then in that case plasma treatment followed by aqueous cleaning before coating if you're?
I don't think that you will do both. You will one or the other would normally be very good. As you said, most people still don't clean at all, and as we heard before, I fully agree with that. Especially if you use a solvent-based system, you still can kind of wash off these residues with the solvent inside of these coatings. But as soon as you use solvent-free materials, it really gets critical.
Right. David, do two-part materials, they have a better surface tension? Do they have a better adhesion quality?
Sorry.
The two-part materials.
Two-part materials, we have only one two-part
Right.
in our range, and it's an old product. It's an epoxy. These days we concentrate on single-part products.
Right.
And of course, in this current era, 100% solids, no solvents, are growing, and as we both described, adhesion can be a problem, contaminants can be a problem. With a two-part, it will be the same.
Right.
You're not going to get any additional benefits from having a two-part, in my opinion.
Okay.
Yeah, so as you said, it's not a general rule that two-pack systems adhere better than one-pack systems. It depends pretty much on the system. Potentially, you have a better chance with a two-pack system to get a really good adhesion, but it always depends on the substrate and the coating, at the compatibility between these two.
Yeah, I agree. So, Axel, what are the biggest challenges you come up against when you're inspecting coatings?
Yeah, the challenge is, first of all, as I mentioned, the board design, so that we find proper places to measure the thickness, to get a good reflection of the surface. Challenges are, I would say this is, in our case, the most challenging point. The material, as long as it is semi-transparent or transparent, we can measure it. So
you don't get any reflective problems or anything like that?
No, because the reflection is the part we need for the measurement.
Right.
And the other part is when we look onto the UV side, but this is nothing new, that we have sufficient fluorescence of the material. So, and the UV side, we try to optimize with artificial intelligence, so to find specific bubbles for specific materials, so that we teach, for example, on customer side with AI engines, the bubbles and the defects, the 2D defects of the customer. So these are the challenges, but it's not so big. It's more now to find the best way to fit the inspection into the customer process. Should we measure the wet material or the dried material? What's the better way? The wet material you can coat again or clean and coat again, something like that. So if you look at the wastage costs, or is it better to work with the dry material? But the experts are here,
Right.
So maybe they can answer.
I would think you'd want to work with the cured coating, surely.
And with some of them, we are already in contact and measure already the materials, doing lab tests, how good we can measure the thickness on Humisil, for example. So I remember the samples we have in our lab. So there's already close communication, and I think this is the key, and this is the challenge to set up the right context to the material suppliers, to the experts, and to find then the best parameters and solutions to develop a stable measurement process.
Yeah. What do you think about that, David? I mean, I would have thought measuring the cured material would be the...
I'm in favour of measuring the cured material, and you know, the client should be doing his trials, doing his application trials, compatibility trials, as we were discussing just now, and working with you guys to make sure he's got that thickness where he needs it, and to refine the process. And then, once he's got his process refined, use it as a process validation system, so that he knows that there's nothing slipped in the process.
So, Marcus, you know, let's look at some of the defects that you typically get in coating systems. I mean, bubbles, peeling, orange peeling as they call it. Which are the most prevalent and which are the most challenging?
Sorry.
I'm talking about the defects that you're likely to get in the conformal coating process. Which are the most prevalent and which are the most challenging?
Yeah, maybe adhesion is a big issue. As soon as you will have a lack of adhesion, you will have subsequent all the other problems, like humidity can get in, and you can cause dendrite growth, and in the end shortcuts. I think, really, that to get a good adhesion and a uniform layer of coating without this de-wettings and interruptions in the coating, I think that is essential to get a good result. In the end, you get what you want to achieve with the conformal coating, a good reliability in a harsh environment.
Great. Yeah. Okay. Anything to add to that?
I think on the bubble front, a lot of the classic coatings have been around for a long time. Originally designed for dip coating and hand spraying, but now being applied by film coaters, etc. So we certainly are looking at our solvent blends, and we are updating some of our classic products to release the bubbles before the product cures. And we've worked with application systems to prove this. And in fact, at this show, we've released our 1B73/730-EU. Bit of a mouthful, sorry about that.
Okay.
And you know, that's one of our first ones we've re-engineered.
Right. That's a good question, actually, because I mean, the electronics industry is exploding at the moment with new applications and new products coming into the market, which are working in different types of operating environments. So are you being challenged by your customers to come out with new coating solutions to deal with this?
Yes, of course. For instance, EV is a big trend, and we see some new demands. High voltage is another things, or high frequency applications, and these require some new technologies, even from the coating side. And this is something we are working in our research and development on, with some partners from the industry, of course.
Yeah.
This I can underline. So all our big projects currently running are driven by EV industry, and they are really the drivers forcing their suppliers to measure coating thickness and coating coverage. So they identified this as a very critical point. So I expect a big rise in this industry, but it's due to the high voltage and everything. I think it will be much more challenging for you guys. So now.
Okay. Last word to you, David.
Okay. Thank you for that, Trevor. I'll back up what you were saying about the automotive industry, about EV. I mean, what we're seeing is thermal cycling. Whereas you do 100 cycles, 125 cycles in the old day, we're now doing anywhere between 1,000 and 3,000 cycles, and they're expecting it to survive that. And the extremes, as I described earlier, -65, +150, is now the norm.
Right, and I heard this week that they're expecting it to go up to 165.
Yeah. Oh, yeah. And you know, we got some people that are talking 200.
Oh my goodness.
So, and it's it's the current, it's the heat that's generated by these electronics in the EV systems.
Right. Well, certainly plenty of challenges ahead of us, gentlemen. So it makes it an exciting and fun industry to be in. So I want to thank you for coming in and joining us today. Marcus Weiler from Peters Corporation, David Greenman from Humasil Chase Corporation, and of course Axel Lindlof from Co-Young. Yep. So thank you, gentlemen, and thank you to our audience for watching today.
Thank you.
Co-Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Co-Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
In an EMS world full of supply chain challenges, pandemics, and shifting deadlines, Global SMT TV works around the clock to keep you up to date with the latest process technologies, standards, and breaking industry news to keep you at the top of your game. Global SMT TV, bringing you one step closer to your goals.
it needs to change the text on it. Just call it. Just live at SMTconnect.
Call it show wrap up.
Show wrap up. Okay.
Yeah. Yeah.
That's all right. Let's try it. Probably need to switch out back to the. Go back to the. So it's day 3 wide. Just go back to that, shall we?
You want to go back to the scene where we were.
Yeah, the live.
Yeah. So that was. The,
Oh, you mean? Yeah.
Yeah. Go back to this.
What do you mean? What I had up?
These. No. We shouldn't be doing this.
Yeah, because we're broadcasting this. Maybe just put that back.
And welcome to our last interview of the day, the show wrap-up. I'm delighted to be joined by Petra Harberger, who's basically ahead of the Misago shows, all of them, including SMTconnect.
Yeah, definitely. But today it's about SMTconnect, I guess, because this is what we're here for, right?
Absolutely. Well, you know, this is the third day, Petra, and I know there's been a lot of happy exhibitors here, but what have been the main takeaways that you've had from the show?
Well, I think the main takeaways is the happy faces I've seen. And happy faces because everybody saw the customer in person again, and that there's nothing else but, or not nothing else, but the most important thing is the personal interaction and the personal meetings. And I think everybody here was here to really make business, to meet the customers, to meet and look for solutions. And this is what I saw on the show floor and on the different booths. And that was just wonderful to see it.
Yeah, I believe you. I mean, it's very hard to replace in-person meetings, you know. I think it's one thing where we were forced to do meetings over Zoom and this type of thing when you're talking to customers, but you miss out some of the body language, the interaction, etc. Not to mention, you don't get to see the machines. So I think it's critical that we get back to having in-person events.
Definitely.
Yeah.
And I think what you just said, in addition, some digital tools are good. And I think that will remain. But I think at the end, it all comes back to this physical meeting, and the rest, I would say, is digital additions that help to maybe foster what you met or saw in the show floor, and then continue talking about it, or maybe do it in advance. So I think it was really cool being here. And
right. So do you think then in the future that these shows are going to be more hybrid events in as much that if you've got a real reason to be here, you will be here, you'll have your in-person meeting, but those that can't get permission to come, for example, will tune in from remotely?
Well, the question is, what is hybrid? You know, the question is, what is a hybrid event? And what we've learned throughout the last 2 years is that some things work digitally. I mean, maybe just content-wise, you know, you can just maybe listen to some lectures or something. But if it comes to business, I think then you need the person-to-person meeting. You need this body language thing, this interchange, and also to look as, is that what the one you want to do business with? You know, it's a personal thing. But getting to the hybrid, I think hybrid will not actually happen in parallel. I think most people, if you're here on the show floor, you will probably not have any time to do something digital in between. But this will be something where I think it's maybe in advance, maybe for preparation, maybe like a warm-up event, maybe where you can maybe already see what's happening on the show floor, prepare yourself, maybe even doing some, I don't know, connections in before, and then you meet on the show floor, and then maybe what you said, if there's some maybe streaming of certain forums or something, I think that might be something that might be interesting for people who could not come to at least get a little bit of a glimpse of what's happening on the show floor. So I think it's more of a digital edition with ADD and not a digital edition with E. So this is, I think, what will happen.
What will happen, yeah. Okay. What's the plans for going forward? I mean, do you think there's been quite a lot of discussion this week about PCIM, which is the next door show? It seems to have been quite a bit busier than SMTconnect.
Well, I guess this is always this perception: is it busy or not? I mean, we will look at the numbers at the end. I think we were really happy with what happened here, and I think the PCIM, I mean, it's the power electronics, is a very rising technology at the moment.
Right.
So I think there's a lot of business there, and we have a conference there in parallel. So I think it's not really something you can compare. So I think, from what I learned here when interviewing and looking at some of our exhibitors, they were really happy. So, and I think you just said something that it's not about the quantity at the end. It's
No,
about
absolutely not. It's
the
the
quality,
quality.
and I think the business been made with maybe 5 people is more important than the business you don't do with 10 people who just wanted to look. Yeah, so
that's absolutely true. As I said, you know, in some bigger shows where you've got a lot of traffic going past your booth, you end up with somebody coming on and asking, how does this work? Who's got no intention of buying it, doesn't know anything about it, he's just curious. But then, on the other hand, the customer that you do need to speak to is walking past because he sees you're busy. So there's absolutely an argument for having a quieter but more focused event with real customers, real buyers on the floor.
Yeah. And I also think that this will be the future, actually, that this more, I would say, specific, very targeted, maybe little smaller events, I think will be more successful than the big shows, because, as you said, I think it's harder also for the visitors to find where do you want to go, what's the solution you look for. And I think here it's quite clear, because it's a very focused show on the electronic production. So I think this is good.
Right.
Yeah.
No, I absolutely agree. So what's next? Do you get any plans or ideas for the show going forward?
Well, I think, as I said, I think now everybody's happy to meet again, and what we think about is actually also prolonging something. I mean, you have probably heard about the insights that we started. This is exactly this content-driven topics that you can do digitally, where it's really about what's happening, about the technology. It's not about buying something, but it's about being educated. So I think to grow that further and to see what the community really wants.
Right.
This is something we work on, because this is something we've learned during the last 2 years, that things do work, and we do this together with our customers. So what we do is we're in contact, we discuss with them what they need, what they want, and especially after these 2 years, I think you already experienced that as well, this digital fatigue in a certain way, which is there. So I think it might also take some time until we really find out what's the right balance between this maybe digital educational stuff and the show where everybody wants to go.
Right.
So,
Okay.
yeah.
And then after we've worked all that out, we'll all be the next thing will be the metaverse.
Yeah, yeah. Well, I guess as you said, I think let's just go through this and experience this, and also I think celebrate this a little bit, because I think this is why people are happy, is because they meet.
Yeah.
And the rest, I think, as I said, I think it's very clear that this will remain, this digital versions. We will see what happens, but this is also very, very dependent on the different communities.
Yeah.
Because you just said we have different shows at Misago as well, and you can see, let's put it like that, the AM community, additive manufacturing, they are completely different when it comes to digital than the SMT community.
Yes.
Yeah, so, and this is something we have to look at. It's not like what we want. The important thing is what the customers want and what serves them.
Right.
And this is what we will look at.
Yeah, it's definitely not one size fits all,
No.
but certainly what I can say, Petra, is that it's absolutely worth celebrating the fact that we returned to SMTconnect this year. It's been a very successful show for a lot of people. There's a lot of happy faces around here, so congratulations and thank you for coming
and thanks for having me, and hope you get back with lots of good ideas and also good memories from here. That's wonderful.
Absolutely, I always do.
Okay, great.
Thank you.
Thanks, Trevor.
Okay. And that takes us out.